Hello guys, my name is Mayur Naik. I'm studying in SVC Bangalore at IAC department. So today we'll be learning about OSI models and their applications. So first let us see the contents of today's topic. So here we have what is an OSI model. Then second we have types of OSI model, and at last we have applications of OSI models. So before going to the layers of OSI models, we should see what is an OSI model. So OSI model, so it stands for Open Systems Interconnections. Model is a conceptual framework that standardizes the function of telecommunication or computing system into seven abstraction layers. So basically, it has seven layers. So it was developed by International Organization of Standardization, that is ISO, to facilitate communication between different systems and devices. OSI was published in 1984. So each layer on the OSI model represents a specific set of functions, and the model is designed to promote interoperability between diverse networking technology and protocols. OSI model is consisting of seven layers. So these seven layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So we'll see what is OSI layer. We'll see what is physical layer. So physical layer is transmits raw bit stream over the physical medium. Then second we come to data link layer. So it defines the format of data on the network. Third we have network layer. So that's it decides which physical path the data will take. At fourth we have transport layer. So transmits data using transmission protocols including TCP and UDP. Then at fifth we have a session layer. So it maintains the connection and is responsible for controlling parts and sessions. Then we have presentation layer, ensures the data is in a enable format and is where data encryption occurs. At last, there is application layer, that is human computer interaction will be taking place. So let us go through physical layer in detail. So the physical layer, the foundation level in OSM model, manages the actual transmission of raw binary data over the physical medium. It uh, encompasses functions like encoding signals, determining physical topology, and defining the transmission media components. Components includes cables, connections, hubs, and NICs. So the characteristics involves bandwidth, data rate, and physical addressing with MAC address. Transmission model includes simplex, half duplex, and full duplex communication. So challenges like noise and interference are addressed through the technique like shielding, then adherence to standards such as IEEE 802.3 for Ethernet ensures the compatibility. Then we have interacting directly with the data link layer. It provides bit stream for encapsulation. In essence, the physical layer is essential for reliable data transmission and network connectivity. Then comes the data link layer. So the data link layer, it is the second OSI model, oversees reliable point-to-point and point-to-multipoint communication between direct connected devices. It involves framing data into packets, error detection, and connection through mechanisms like CRC. So sub-layers such as logical link layer, that is LLC, and media access control manages flow control and address resolution. Then devices like switches and bridges separate at this layer, making decisions based on MAC address. Ethernet and Wi-Fi standards are implemented here. The layer ensures efficient and error-free data transfer within a local network. Its interaction between the physical layer involves the conversion of frames into bits for transmission. The data link layer plays a crucial role in creating a robust and orderly link between devices in a network. Then we have network layer. So the network layer position is third OSM model focuses on logical addressing, routing, and forwarding of data between devices in different networks. Then it uses IP address for unique identification and employs the routing protocols to determine the optimal path for data transmission. Notable examples includes Internet Protocol as IP and Internet Control Message Protocol (ICMP). So routers operating at this layer makes a decision based on network layer information. The layer ensures end-to-end communication by managing logical addressing and packet forwarding. It abstracts the underlying physical network, provide the unified interface for higher layer protocols. Network layer plays a crucial role in enabling inter-network communication and facilitating the flow of data across the uh, diverse network infrastructures. Then we have transport layer. So transport layer is the fourth in the OSM model, is responsible for end-to-end communication and data transfer reliability. It segments and resembles data into manageable units called segments, ensuring efficient transmission. Protocols like Transmission Control Protocol as TCP provides reliable connection-oriented communication, while User Datagram Protocol as UDP offers faster connectionless communication. Flow control mechanism prevents uh, cohesions and ensures proper data delivery. Then error detection and corrections mechanism enhances data integrity. Then the transport layer facilitates multiplexing and due demultiplexing, managing multiple connections simultaneously. Its function contributes to establish maintenance and termination of sessions between applications. Overall, the transportation layer plays a crucial role in ensuring data integrity, reliability, essential communication between devices across a network. Then we have session layer. So session layer is the fifth oversight layer, managing the establishing, maintaining, and terminating of sessions or connection between application on different devices. It enables synchronization and dialogue control following for full duplex or half duplex communication. Session layer service includes checkpointing, which allows for the recovery of data after a connection failure. The synchronization points for essential data exchange. It ensures that data is properly organized into manageable units called data chunks. This layer provides services such as tokens management and dialog control, enhancing the reliability of data transfer between applications. In summary, the session layer facilitates and controls communications sessions, contributing to the orderly and efficient exchange of data in network environment. Then we have presentation layer, which is the sixth layer, focused on ensuring the compatibility of data formats between applications of different devices. It translates and formats data into standardized syntax for transmission and reception. Encryption and compression technique are applied in secure and optimized data during transfer. Then the layer acts as a bridge between application layer and the lower layers, handling data transformation and ensuring that it is readable format for both sender and receiver. Then we have something else MIME, that is multiprocessing internet mail extension, and JPEG are examples for encoding standards utilized in this layer. At last, we have application layer. So the application layer is the last and seventh layer, and it is also the topmost layer in OSM model. It provides a network interface and end user application, enabling communication between software and the network. It encompasses a variety of high level protocols and specifying applications such as HTTP for web browsing, SMTP for email, and FTP for the file transfer. The layer handles user authentication, authorization, and communication with the lower layer. It allows multiple applications to share and network simultaneously, supporting diverse user activities. Then in essence, it serves as a point of interaction between the user and the network infrastructure, making diverse application accessible over the network. So as we are done with all the OSI models, so we should check to see what's the application of the OSI layers. So first we have network design and troubleshooting. OSI model serves as blueprint for designing and troubleshooting network architectures, providing a structured approach to understanding and addressing uses of specific layer. At second, we have interoperability. By defining a standardized layer and protocol, the OSI model promotes interoperability between different networks, technologies, and devices, allowing diverse systems to communicate seamlessly. Then we have protocol development. It guides the development of network protocols, ensuring that each layer has a specific set of functions, which simplifies the creation and implementation of new communication standards. At fourth, we have communication standardization. The OSI model facilitates and standardization of communication protocols, enabling widespread adoption and compatibility among network devices and software applications. At fifth, we have training and education. It serves as fundamental concept in networking education. And sixth, we have vendor independence. So the model allows the creation of networking products and solution independent of specific hardware or software vendors. Then we have security implementation. So security measures can be implemented at various layers. Then at eight, we have model of comparison. The OSM model provides a reference framework for comparing different network architectures, making it easier evaluate the strength. Via communication protocol evolution, as technology involves OSM model has been adaptable servicing as basis of development and evolution of communication protocols such as TCP and IP. At 6, we have cross-function collaboration. The model fosters collaboration among professionals in different IT disciplines, as it offers a common language and framework for decision and solving complex problems in realm of network communication. Thank you guys.